NENOMATICA, where mathematics meets YouTube excellence. Scientific notation. Welcome to this educational video on scientific notation for very small numbers. When dealing with extremely small quantities in science and mathematics, writing all those zeros can be cumbersome and error-prone. For example, the mass of a dust particle might be 0.000000067 kilograms. That's a lot of zeros. Scientific notation helps us write these numbers in a more concise and manageable form. Scientific notation represents a number as a product of a coefficient between 1 and 10 and a power of 10. For very small numbers less than 1, we use negative powers of 10. The general format is a times 10 raised to the power of negative b, where a is a number between 1 and 10 and b is a positive integer. Let's learn how to convert a very small number to scientific notation. Consider our example of 0.000000067 kilograms. Step 1. Move the decimal point to the right until you have a number between 1 and 10. In this case, we need to move the decimal point 9 places to the right to get 6.7. Step 2. The number of places we moved the decimal point becomes the negative exponent of 10. So 0.000000067 equals 6.7 times 10 raised to the power of negative 9. Let's try another example. The size of a bacteria might be about 0.000005 meters. Moving the decimal point 7 places to the right gives us 5. So the scientific notation is 5 times 10 raised to the power of negative 7. This can also be written as 5e negative 7, where e stands for exponent. Let's compare standard decimal notation and scientific notation for some very small numbers. As you can see, scientific notation makes it much easier to read, write, and compare very small numbers. Scientific notation has several advantages. It eliminates counting zeros, reducing errors. It makes calculations with very small numbers more manageable. It helps us understand the scale of the number at a glance. Scientific notation is extensively used in various scientific fields. In physics, chemistry, biology, astronomy, and many other disciplines, scientists often deal with very small or very large quantities. For example, in physics, the mass of an electron is approximately 9.1 times 10 to the negative 31 kilograms. In chemistry, the size of an atom might be around 1 times 10 to the negative 10 meters. And in biology, some viruses can be as small as 2 times 10 to the negative 8 meters. Let's look at our first example. We have the decimal 0.005. To convert this to scientific notation, we need to move the decimal point until we have a number between 1 and 10. For 0.005, we need to move the decimal point 3 places to the right to get 5, which is between 1 and 10. Since we moved the decimal point to the right, the exponent will be negative. So 0.005 in scientific notation is 5 times 10 to the negative 3. Let's move on to our second example, 0.000061. Again, we need to move the decimal point until we have a number between 1 and 10. For 0.000061, we need to move the decimal point 5 places to the right to get 6.1, which is between 1 and 10. Since we moved the decimal point to the right, the exponent will be negative. So 0.00061 in scientific notation is 6.1 times 10 to the negative 5. Now let's look at our third example, 0.1275. Following the same process, we'll move the decimal point until we have a number between 1 and 10. For 0.1275, we need to move the decimal point 1 place to the right to get 1.275, which is between 1 and 10. Since we moved the decimal point to the right, the exponent will be negative. So 0.1275 in scientific notation is 1.275 times 10 to the negative 1. We're given the decimal number 0.0004892, and we need to convert it to scientific notation. To convert a decimal number to scientific notation, we first need to identify the first non-zero digit. In this case, the first non-zero digit is 4. The next step is to move the decimal point, so it's just to the left of that first non-zero digit. we'll need to move the decimal point 4 places to the right. Remember, scientific notation has the form a times 10 to the power of b, where it is a number between 1 and 10, and b is an integer. Since we moved the decimal point 4 places to the right, the exponent in our scientific notation will be -4. So our answer is 4.892 times 10 to the -4 power. This can also be written as 4.892 times 10 to the power of -4. Let's see another way to look at the same number. We can write 1 over 20,000. We can convert this to a different form by rewriting the denominator. 1 over 20,000 equals 1 over 2 times 10 to the 4th power. Now we can rewrite this fraction as 1/2 times 10 to the -4th power, which equals 0.5 times 10 to the -4th power. And we can also write this as 5 times 10 to the -5th power, which equals 5 times 10 to the power of -5. Welcome to our math video. Today, we're going to learn how to convert scientific notation to decimal representation. Let's start with our first example, 5.2 times 10 to the -3 power. When we have a negative exponent in scientific notation, we move the decimal point to the left. The absolute value of the exponent tells us how many places to move. For 5.2 times 10 to the -3 power, the -3 means we move the decimal point 3 places to the left. So we get 0.0052. Let's move to our second example, 6.02 times 10 to the -2 power. For 6.02 times 10 to the -2 power, we'll move the decimal point 2 places to the left. This gives us 0.0602. Now for our third example, 7.304 times 10 to the -5 power. For 7.304 times 10 to the -5 power, we move the decimal point 5 places to the left. We'll need to add leading zeros to get 0.0007304. Let's continue with another example, 2.543 times 10 to the -3 power. For 2.543 times 10 to the -3 power, we move the decimal point 3 places to the left, resulting in 0.002543. Welcome to this math video on scientific notation. In this video, we'll learn how to convert decimal numbers to scientific notation. Scientific notation is a way of expressing numbers that are too large or too small in a more compact form. It's written as a product of a number between 1 and 10 and a power of 10. Let's look at our first example. We need to convert the number 0.000000067 to scientific notation. To convert this number to scientific notation, we need to move the decimal point until we have a number between 1 and 10. In this case, we need to move the decimal point 9 places to the right to get 6.7. Now, we need to multiply this by 10 to the power of -9 because we moved the decimal point 9 places to the right. This follows the rule that when we move the decimal point to the right, we use a negative exponent. Therefore, the scientific notation is 6.7 times 10 to the power of -9. Let's look at our second example. We need to convert 0.0004567 to scientific notation. Again, we need to move the decimal point until we have a number between 1 and 10. In this case, we move the decimal point 5 places to the right to get 4.567. Since we moved the decimal point 5 places to the right, we multiply by 10 to the power of -5. So, the scientific notation is 4.567 times 10 to the power of -5. For our third example, we have 0.0001023 times 10 to the power of -7. This is a special case because the number is already partially in scientific notation form with the power of 10. We need to convert the first part, 0.0001023, to scientific notation, and then combine the exponents. To convert the first part, we move the decimal point 4 places to the right to get 1.023. Now, we have 1.023 times 10 to the power of -4 from the first part. We need to combine this with the original 10 to the power of -7 by adding the exponents. So, we calculate 1.023 times 10 to the power of negative 4 times 10 to the power of negative 7, which gives us 1.023 times 10 to the power of negative 11. For our final example, we have 672 times 10 to the power of negative 17. Here, we have a number greater than 10 multiplied by a power of 10. To convert 672 to scientific notation, we need to move the decimal point 2 places to the left to get 6.72. When we move the decimal point to the left, we use a positive exponent. So 672 is equal to 6.72 times 10 to the power of positive 2. Now, we need to combine this with 10 to the power of negative 17 by adding the exponents. So we have 6.72 times 10 to the power of 2 times 10 to the power of negative 17. Adding the exponents, we get 6.72 times 10 to the power of negative 15. Welcome to our math lesson. Today we're going to learn how to arrange decimal numbers and fractions in ascending order, from smallest to largest. Let's look at our example. We need to arrange these numbers from smallest to largest: 0.46, 0.488, negative 1/2, negative 26 over 50, 505 over 1,000, and 0.47. To compare these numbers, we'll convert all of them to fractions with the same denominator. This will make the comparison much easier. Let's start with the fractions. Let's look at the fraction 505 over 1,000. This fraction already has a denominator of 1,000, so we'll keep it as is. Next, let's convert 0.488 to a fraction. Since there are 3 decimal places, we multiply by 1,000 to get 488 over 1,000. Now, let's convert negative 1/2 to a fraction with denominator of 1,000. We multiply both numerator and denominator by 500 to get negative 500 over 1,000. For the fraction negative 26 over 50, we multiply both numerator and denominator by 20 to get negative 520 over 1,000. Next, we convert 0.47 to a fraction. This becomes 470 over 1,000. Finally, let's convert 0.46 to a fraction. This becomes 460 over 1,000. Now that we have converted all numbers to fractions with a denominator of 1,000, let's summarize what we have. Now, let's arrange these fractions from smallest to largest. Since all fractions have the same denominator, we only need to compare the numerators. The smallest would be negative 520 over 1,000, followed by negative 500 over 1,000, then 460 over 1,000, then 470 over 1,000, then 488 over 1,000, and finally 505 over 1,000. Now, let's write our answer in the original format of the numbers. So from smallest to largest, we have negative 26 over 50, negative 1/2, 0.46, 0.47, 0.488, and 505 over 1,000. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.